Wastewater carries a range of harmful microorganisms, including bacteria, worm eggs, viruses, and protozoa. Depending on the treatment process, some pathogens may be removed or eliminated through digestion, sedimentation, and filtration. Other pathogens may be more resistant and possess characteristics that prevent their complete removal during effluent post-treatment. When effluent reuse or discharge is intended, national regulations or international standards must be met in order to protect public health, and disinfection becomes crucial as the final step of the effluent treatment process. Disinfection refers to eliminating or inactivating pathogenic microorganisms in the effluent. It helps minimize environmental contamination and prevents the transmission of waterborne diseases that can occur through the direct ingestion of untreated water. Food consumption. The infection resulting from skin contact with contaminated water. Various disinfection methods exist, with chlorination and ultraviolet radiation being the most common. To ensure the efficiency of the selected disinfection method, several factors need to be considered. What types of infectious organisms are present in the effluent? Effluent varies in its concentrations and types of pathogens. Therefore, it should be analyzed to determine which harmful microorganisms are present. For instance, if a high presence of parasites, such as Giardia or Cryptosporidium, can be expected, chlorination is ineffective and not a suitable disinfection method. Instead, UV radiation is an effective alternative. Next, the preconditioning or prior treatment should be in place and meet requirements for efficient disinfection. This is especially relevant for organic matter, which must be removed as it otherwise harms the efficiency of disinfection processes. For example, chlorine residuals are unstable in high concentrations of organic matter. Consequently, the effluent would require higher doses of chlorine for adequate disinfection. Similarly, UV radiation is inefficient in cases of high turbidity and elevated amounts of total suspended solids in the effluent. Last but not least, the setup of the disinfection process itself is essential and affects the choice considering local conditions. Each method has different requirements regarding power, consumables, maintenance, contact time to achieve intended results, and more. Additionally, each method's possible limitations and disadvantages must be kept in mind. For example, following chlorination, effluent may be pathogen-free but contain toxic chlorine residuals to aquatic life. In the following module, we will look more at the harmful microorganisms in effluent and the possible disinfection methods to ensure elimination.